Okay, let me ask you something. When you hear the word theory, what's the first thing that pops into your head? Is it a guess? A hunch, maybe? An idea that's not really proven? Well, let's dive right into that because that one little word, it's probably one of the most misunderstood and frankly misused words in the English language.
I mean, you've heard it a million times, right? Someone wants to shut down an argument and they just say, oh, that's just a theory. It's like the ultimate conversation ender. But what if that whole phrase, that whole idea, is built on a massive misunderstanding of what a theory really is? And this, right here, is the heart of the problem. You see, in our everyday chat, theory basically means a guess. My theory is the butler did it. But in the world of science, it's the complete polar opposite. A scientific theory is one of the most powerful, most reliable things we have. It's this huge, evidence-backed explanation for why things work the way they do. And to really, truly get that difference, we're going to have to jump in a time machine and look at a couple of amazing stories. All right, so our first stop is ancient Greece, about 2,400 years ago. And what we find there is this massive intellectual battle, a debate over the very fabric of reality itself.
So the most popular idea at the time, the one championed by the superstar philosopher Plato, was that everything, and I mean everything, was made from just four basic elements: fire, water, air, and soil. It's simple, it's elegant, and pretty much everyone believed it. But then you had this other guy, Democritus, who wasn't nearly as popular, and he had this totally radical, genius idea. He said, look, if you keep cutting a piece of fruit in half, the smallest bit is still fruit, right? If you break a stone, the tiniest piece is still stone. So he figured everything must be made of these incredibly tiny, indivisible particles that he called atomos.
And let's be clear, this was not some friendly, polite academic debate. Oh no, the establishment, with Plato at the helm, saw this atom idea as a huge threat. In fact, Plato hated Democritus and his work so much, he literally said he wanted all of his books to be burned. And well, Plato won. His view dominated. And for an incredible, an absolutely astonishing 2,200 years, the correct idea, that brilliant spark from Democritus, was basically buried. It was lost to history, while the world just kept on believing in those four elements. Okay, now let's fast forward all the way to 1808. We've got an English chemist, John Dalton, and he's in his lab experimenting with gases, and he notices something really strange. Elements always seem to combine in these fixed, predictable ratios based on their weight. And as he thought about it, he realized the only way that makes sense is if they're made of tiny, separate, indivisible units. He had just found the very first piece of hard, experimental evidence for that ancient idea of atoms. And boom, just like that, the atomic theory was born. And notice, it wasn't born as a guess. It was a solid, evidence-backed explanation that today, it's the absolute foundation of pretty much all of modern chemistry and physics. All right, now for our next story. Let's jump forward to the early 20th century. At this point, the scientific consensus, what all the experts agreed on, was that the continents were stuck. They'd been fixed in place ever since the Earth first cooled down. But one man looked at a map and saw something completely different. An idea so wild, so out there, that it was basically considered scientific heresy. So, in 1912, a German geophysicist named Alfred Wegener starts to lay out his evidence. And it's pretty compelling. First, he's like, hey everyone, have you ever noticed how the coastlines of Africa and South America look like they sit together like puzzle pieces? Then he points to fossils of the exact same little freshwater reptile, a Mysosaurus, found in both South America and Africa. Now, this little guy could absolutely not have swum 4,000 kilometers across the freezing, salty Atlantic Ocean. No way. And on top of all that, he found identical rock formations and even whole mountain ranges on opposite sides of the ocean. The evidence was just staring everyone right in the face. The pieces fit, so Wegener drew the only logical conclusion. All the continents must have at one point been joined together in one massive supercontinent. He even gave it a name, Pangaea. So how did the scientific community react to this brilliant, evidence-based idea? Well, they laughed at him. They called it totally irrational and nonsense. They completely rejected it, mainly because Wegener, for all his amazing evidence, couldn't explain how. What was the engine powerful enough to move entire continents? And tragically, he died decades before anyone found the answer. So what happened? What was that missing piece of the puzzle that finally proved Wegener right? Well, the proof came And you're not going to believe this, from the most unexpected place imaginable. The answer didn't come from a geologist. It came from the nuclear arms race. This is a wild story. So during the Cold War, the superpowers built this secret, global network of super-sensitive seismometers. The goal was to listen for enemy nuclear bomb tests. But while they were listening for bombs, the instruments picked up something else. This constant, low, deep rumbling coming from inside the Earth itself. It turns out they had accidentally discovered the massive tectonic plates that are constantly moving, carrying the continents on their backs like giant rafts. And just like that, 30 years after he died, Alfred Wegener was proven completely right. And this is where the power of a theory really shines. We can now measure these movements with incredible precision. For example, we know that the African plate is smashing into the European plate at a rate of about 1 inch per year. Now, that doesn't sound like a lot, but give it time. In about 50 million years, that slow collision will have completely closed up the Mediterranean Sea and buckled the land into a brand new mountain range. Okay, so we've got atoms and we've got continents adrift. Two completely radical ideas that were fiercely rejected at first, but eventually became cornerstone facts of science. So let's pull all these threads together and see what it all means. So let's nail this down once and for all. A scientific theory is not a guess. It's a powerful, well-tested explanation for a whole bunch of facts. It's been confirmed again and again through observation and experiments. And here's the key part. It doesn't just tell you what happens, it explains why it happens. And because of that, it lets us make some incredibly powerful predictions. And you can see the pattern, right? It's the same in both stories. It starts with a simple observation. Hey, those coastlines fit, or matter has to be made of something. That leads to a bold new idea, a hypothesis. Then comes the backlash, the rejection from the established way of thinking. And finally, sometimes years, sometimes centuries later, the evidence shows up that proves the idea right, and it becomes a solid, powerful theory. And look, this isn't just a history lesson. These theories aren't just sitting in textbooks. They are the engines that literally power our modern world every single day. I mean, take Newton's theory of gravity. It's so unbelievably precise that back in the 1840s, astronomers saw that the planet Uranus was wobbling a bit in its orbit. So they used Newton's equations to predict that there must be another planet out there, and they even calculated exactly where it should be. They pointed their telescopes to that spot in the sky, and boom, there was Neptune. Or how about Einstein's theory of relativity? I know, it sounds super complicated and abstract. But here's the thing. If the engineers didn't use Einstein's equations to constantly correct the clocks on GPS satellites, your car's navigation would be off by several kilometers every single day. It would be totally useless. And think about this. The idea that the Earth goes around the sun, that's the heliocentric theory. And it's the only reason we can do something as insane as launch a rocket from our spinning planet, fly it through space for months, and land it with pinpoint accuracy on another moving planet millions of miles away. So, you see, theories are not these fragile little guesses. They are huge, powerful, robust explanations for how the universe works. They're built on mountains of evidence, they've been tested for centuries, and they can make predictions that are just mind-blowingly accurate. They are the very bedrock of our understanding. So the next time you hear someone dismiss an idea because it's, quote, just a theory, maybe something like the theory of evolution, I want you to stop and think. Based on everything we've just talked about, what does that really mean?